In a previous video, we created an interconnect test on the development screen. So in this test, we will go to the test screen, load up that test, and then what we're going to do is run the test, take a look at the failures, and go to the proscan screen to debug them. When we first load the test, a tap test, test access port test, will be run on the on our target board, and that includes an instruction capture test, instruction register length bypass, ID code. Here are the measured and expected ID code values, and that passed. But when we run the full interconnect test, we'll notice that there are quite a few failures and a lot of diagnostic messages. So what we want to do now is go to the proscan screen and take a look at those failures. So what do we have on the proscan screen? There is a list of nets and pins, and for each net there are a list of the boundary scan pins associated with it. This list only includes nets that have scan pins on them. Next to each scan pin is a test vector, and the test vector shows us drive values on pins. That's the yellow. The green are expected values. So in this case, what we see, if we click on this, it will bring, if we click on a waveform, it will bring all of the associated pins and waves together in a test solution for that particular pin. So what we see here is, for example, this pin drives high, that's the yellow, and then it captures a green high, and then all of the other pins involved are capturing green. And so we go back and forth like this. Here we're driving low, and we're expecting low on all of these pins on these nets. So this panel will show us the expected test vectors. It will show us test results. If you see a red area, a red line, that's an incorrect response in the test and test data out. So what else do we have? We can browse and load tests. We have a browse circuit, so if we want to take a more in-depth look at a pin, it'll show us the device. This is a list of all of the devices, scan and non-scan, all of the pins on a particular device, and then on a particular pin, it'll show us all of the pins on that pin's net. For example, resistors, an SRAM, whatever it might be. So using this panel, we can browse around in the circuit if we wanted to go to U1, or let's say we wanted to take a look at the SRAM. We could do that, and in particular we can take a look at the nets on the SRAM. Here is an output enable that goes to flash. Let's see what else. We probably want that turned off during the test, and we did. We set that guard on the guards page. It's driven high, and we can see the address pins on the flash. And so we can browse around as we need to during debug. The other panels here, there is a message area. When we run a test, the diagnostic results will be there. So if we run this test, the one that we ran on the test screen here, we'll see the same test messages that we saw on the test screen and a failure count. Down in this area we have a number of commands. We can wiggle pins. We can select a pin, wiggle pins high and low. For example, let's take this pin. We could wiggle it low. We can wiggle it high, and it shows up over here. We can rerun the test at any point. We can do application sampling. So let's say we Now it's actually in application mode, and if we just want to check for background signal activity on the board, what we do, we can see signals running, and we notice they're clocked. So we might want to come in here and guard these pins. We may want to turn them off if there are active signals. So we can turn off that. We could go into our guards area, pick this pin, and select output off, input off for that pin. Now we could recompile here, but let's take a look at more things on the board. Go back, we could put sample back on, see what else is going on. Okay, here is an area with quite a few clocks, and those are probably going to be difficult to test because of the background clocking activity. So what we can do is just turn that off for the moment, go into guards, and we could set guards on each pin. I won't do it right now, but that is what we can do, and that would help in debugging. Come back over here and rerun the test. We'll get our test vectors back. Notice that the fail count is unstable. That's probably because of these background clocks and instability, and because we haven't set enough guards to prevent contention yet. Over in this panel, we have a list of all of the tests that we're doing. As we scan through the various shorts tests, we notice that the vectors move. So what we have is a tap test at the beginning, then we have opens tests, and we have some bus connections on the board, so there are a number of opens tests as we let each pin on the bus transmit to the other pins. And then there are quite a few shorts vectors as we try to capture all of the shorts conditions on the board. I'm going to go ahead and set some guards on many of these pins. So guards have been set on quite a few pins, and these particular pins we can't test because they're differential pins that go to another device that's not in the scan pin, so we don't have the correct bidirectional capability. So what we're going to do is just go ahead and compile what we have with the changes that we've made. Okay, the compile is completed, and we will now run the test. And so we've gone from about 250 failures down to 91 failures. So let's see what those failures are. We'll go to the find first failure, and we take a look at this. The prog B pin should be held high during the test. So what we want to do is go over here to guards, drive that output high. This pin I know will always measure a low, so we're going to pick it, and we're going to sense input low. These two pins have some failures on them, and it might be that we could debug them, but just for the sake of expediency, what we will do is we'll just turn off the test on those pins for now. And now we'll recompile again. Compiling is completed. We'll rerun the test. Now we're down to 89 failures. Okay, this pin here we're going to turn off the test on that. What else is failing? We can scan through here. We can take a look at what's passing. There's quite a bit passing. See all this green? Yellow are the signals driving. Here on these pins, these are self-monitoring pins, so it's driving and capturing on the same bidirectional pin. There aren't any other scan pins on that network. So we look through here. This is another differential pin that we don't have all the connections to test, so we're going to turn that off. At least not in this setup. So we'll scan down through more pins, more tests. There's a lot being tested. The SRAM flash. Okay, U1 pin AA14. We'll turn that off for the moment just to get through this debug as quickly as possible for demo purposes. We'll turn that off and we'll recompile. Okay, it's completed. Now we'll rerun the test. Now it's saying pass. So here is our test, and if we set a failure on the board and run the test, we notice that we now, what I did is I just flipped the dip switch. We now see that we get a diagnostic message that it's stuck high. So let's go back to the test screen now that we have a test. We'll browse, load up our test. The tap test still works. If we run our test, we'll see our diagnostic message. If this dip switch is stuck high, we'll flip the switch to another position and we'll run it, and now it passes. So that's a quick overview of proscan and the procedure to debug tests. Thanks for watching.